On your follow-up homework problem. I'm going to show you kind of how to set up this homework problem from both methods that we talked about. So how you would set it up if you wanted to treat each mass as a separate system versus how you would set it up if you wanted to treat both masses as a single system. So if we're going to start with the separate system, then we want to draw our free body diagrams for each mass separately. And M1 is going to have force normal up, force gravity down, and force tension to the right. Notice there's no friction because if you read the problem, it says that we assume that the surface and the wheels are frictionless. We also need to draw a free body diagram for M2, and we know that force tension is the same throughout a string, so I've indicated that with my tick marks that they're the same. And there you have it. I've also clearly shown that force gravity of M2 is greater than force tension because it's accelerating down, and force tension is greater than nothing because there's no friction because it's accelerating to the right. Well, there you've got kind of a hint at how we're going to draw our axis of acceleration, and there you have it. We're going to draw our axis of acceleration like that because this cart's accelerating to the right and this cart or this mass is accelerating down. So you can then know what positives and negative signs you would assign to these forces and this force. I think if you want to try and approach the problem using this method, I've given you enough information to get started. But let me help you set up the problem if you want to treat it as a single system. Again, we will start by clearly illustrating our system. I put a dotted line around M1 and M2 to show you that I'm thinking of these as just like one object, not two separate ones anymore. And the object is accelerating like this, right? So it's accelerating like that so we can draw our axis of acceleration for it. And then we want to think about what forces are external to it and what forces are accelerating it this way or opposing the acceleration horizontally on M1, and what forces are accelerating it vertically or opposing that acceleration on M2. But we only want to include forces that are outside of the system, so we're not going to include those tension forces. And as a result, the only force that is working to accelerate the system is force gravity of M2. So that is the only force that you're going to use in your net force equation because tensions are both inside the system and there is no friction in the system. There you have it. I think with this advice you can successfully solve the problem. Good luck, and I hope this video was helpful to you.